Good afternoon, Esther. How are you doing this afternoon? I am doing well. Thank you for asking. Hi, Isabel. How are you doing this afternoon? All right. The next 6 weeks are going to be pretty intense. There's a lot of material. We're going to be doing a lot of reviewing. AP exam questions, especially the free response type questions. We'll be going over a lot of those. We'll be doing multiple choice questions. We're going to go back and review limits, derivatives, integrals, all of that kind of stuff to get you ready for the exam. Like this week, you'll notice, I don't know if I have the pace chart. Yep. You'll notice that we're reviewing the F prime graphs. There is always an F prime graph on every AP exam. You will never, and this week, you'll have an assessment that has 3 or 4 of them on there. I think I have one on the end of this week's practice, or this week's main lesson we'll go through. I wanted to start off today by doing a couple of the problems. Isabel, you said you were struggling with some of the problems on the multiple choice test. And so I'm going to go through a couple of them. I'm not going to go through a lot because we do have some new stuff to cover today. Do both of you guys have a graphics calculator? Okay. Do you know how to use it? For example, do you know how to find the derivative? It won't find the derivative, but it will find the value of the derivative for you. Like if I gave you something like if I gave you, okay, I will show you. Well, I'm not sure if I'm going to be able to show you today. I'll try to explain it. Hopefully you have your calculators in front of you. I've got a TI-84, but I'm not exactly sure how to share it with you guys. So I'll show you how to do it on Desmos, and most of the times it's very similar on your graphics calculator. Okay. So here's one of the problems that was on the free response. I think it was on. This is a non-calculator type problem, and this one was. I think you, Isabel, you said you were struggling at starting at number 10, and this was number 10, and then I just picked and choose a couple of problems. So anytime I see something like this where it asks me that it gives me f of x, and it gives me an integral, and it wants me to find f prime of x. This is f prime of x when you think about it, because if you take the integral of the derivative, you go back to the original function. Anytime you see a t, it's a big clue that they just want you to plug this in for the t. So really, in this problem, I want to make sure this marker is a little bit thinner here. So in this problem, all I had to do is I had to just plug this in here. So this would be the cosine of the natural log of x. But remember, if this is not just x in the integral, we have to take the derivative of that and multiply it to this. Well, the derivative of natural log of x is 1 over x. So I would have to multiply that on there. So my answer would just be cosine natural log of x over x. Letter D. And that is one of those ones, that was, what is it, the Fundamental Theorem of Calculus Part 1. When we did that week's work, it was like the easiest stuff in the world. It was like, they gave us, and then they wanted us to take and all you do is you just plug in the t value. The only thing that messed some kids up is, if this is anything other than an x, you've got to take the derivative of that and tack it on. So that is how you would have done that type of problem. Now, please, if there's any questions, please jump in anytime. Nobody ever hurts my feelings. Now, this problem here, it says, which of the following is a solution to the differential equation? Well, this is exactly what we just finished doing. If you think about it, they're asking us to find the thing here. So step number one, we have to split up the variables. We have to get dy. So I'm going to put the y squared up here is equal to secant squared of x dx. Well, my next step would be to take the integral of both sides, right? So if we take the integral of both sides, don't we just end up with, let's see here, so isn't this y to the third over 3 is equal to, and secant squared is going to be tangent of x plus c. Okay, and then my next step would be to get the my next step, if I had, I would try to find the c value. They don't give us a value to plug in. Okay, so I would multiply both sides by 3. So if I multiply both sides by 3, you multiply this by 3. Well, 3 times c is just c, right? It doesn't, a constant is a constant. I don't care if you multiply by 3, if you multiply by 10, it's just a constant. Okay, and then my last step would be to take the third root of both sides. So my answer would be the third root of 3 times tangent of x plus c. Well, they have 1 in all of their answers, so I'm just assuming that 1 is going to be my c value. C is a constant. It doesn't matter what the constant is, it's still going to be the same thing. So my answer should be letter C. And that was very similar to what we just finished right before spring break, trying to split those variables up and rewriting the problem. All right, I think I have one more problem. Now this one kind of stumped me because I thought this was a 4 here. It's not, it's a 2. That's a 2 there. Now this is a very interesting problem. It says that g of x is equal to f of x squared. What is g prime of x? Well, I'm looking at this, I'm saying, okay, so if I have to take the first derivative, I'm taking the first derivative of this. Well, this is a function. And remember, when we take a derivative of a function, we take the derivative of the function, we leave the middle alone. This is the chain rule, times the derivative of the middle. So that would be the first derivative. So now when you start seeing more and more of these types of problems, you'll be like, oh, I get what they're trying to do. They're seeing if you understand the chain rule. And then the next step is, do you understand the product rule? Because I need to take the next derivative. So g double prime of x would be the derivative of this. Well, this is a function here. So I'm going to use the chain rule, or I'm sorry, the product rule. So I'm going to let u equal f prime of x squared. So the derivative of that would be f double prime of x squared times 2x, because you take the derivative of the function, leave the middle alone, and take the derivative of the middle. And then v, my second function is 2x. V prime is equal to 2. Remember, product rule, it's inside. So I've got 2x times 2x, well, that's 4x squared. And I still have that f double prime, so 4x squared f double prime of x squared, plus the outside. That would be 2 f prime of x squared. And I believe that is letter D for that one. I don't think I have another question on there. Maybe I do. Nope, I do. Okay, so in this problem, this goes back to first semester. It says, for what values of x is the function f of x equals 1 plus x squared minus 2x to the fourth increasing? Well, that is the first derivative test. What does the first derivative test give us? First derivative test tells us where a function is increasing, decreasing, what its max and mins are. So how did we do that? Okay, well, to find the first derivative, to use the first derivative test, we have to, and I'm just writing this in normal standard form, we have to take the first derivative. So that gives me negative 8x to the third plus 2x equals 0. Then we have to figure out where it equals 0, because that it gives us a max or min. So I'm going to pull out a negative 2x here. So that gives me, what, 4x squared plus 1. Is that right? 4x squared plus 1. I think that's right. Nope, I think it's minus. It should be a minus sign here because I'm taking out a negative. So this can be factored even farther. So negative 2x. So that gives me 2x minus 1, 2x plus 1. So where does this function equal 0? It equals 0 at 0, 1/2, and negative 1/2. And then we made that table up. We made the first derivative table up, f prime of x, and then we did negative infinity to negative 1/2. Negative 1/2 to 0, 0 to 1/2, and 1/2 to infinity. And then what we do is we check each one of those intervals. How do we check? We just plug it back into this. Is it positive or negative? So let's take a value in here. Let's take negative 10. So I put negative 10 in here. Negative 10 times negative 20, that's positive. And remember, we don't need the value. We just need to know if it's positive or negative. So that's positive. If I put negative 10 in here, that gives me negative 20 minus 1. That's a negative. If I put negative 10 in here, that's going to give me a negative. So positive times negative, that's a positive. This function is increasing from negative infinity to 1/2. I know that. And then between negative 1/2 and 0, I'm going to go negative 0.25. So I put negative 0.25 in here. That gives me positive in this first term. Negative 0.25, that gives me a negative. That's going to be negative. And if I put it in here, or is that going to be positive? Oh, that's going to be positive because that's going to be less than 1 or more than 1. So that's going to be positive here. This is going to be negative. This is going to end up being a negative. And then I would find this one. It's positive, negative. So decrease, increase, decrease. So where it asks, where is it increasing? It's increasing from negative infinity to negative 1/2. It's also increasing from 0 to 1/2. So my answer, x is greater than 1/2. Nope. 0 to 1/2. Yep. X is less than negative 1/2. Yep. So that's going to be my answer. So those are some multiple choice questions off of that review. When you get to the AP test, they are all mixed up all over the place. Any questions on those? And each week I'll throw a few more at you and we can go through them. But it's a lot of review. And we'll be doing a lot of that in the next 6 weeks. All right. Now, this week, what we're doing, we're going to do linear motion revisited. We're going to be talking about particle motion. When you know what an integral is, we can find the area underneath curves. And the area above curves means the particle is moving to the right. Area underneath the curve means it's moving to the left. So if we want to find displacement of a function, okay, displacement is the difference from where it starts to where it stops. So all you have to do is take the integral of the velocity function. If you take the integral of the velocity function, you will get the displacement. If you want the total distance traveled, well, then what you really are doing is you're going to make this positive, and this positive. Because remember, if I had a function and if it starts and it goes off in this direction 10 units, but then it comes back, let's say 5 units, and then it turns around and goes back 15 units, well, where does the displacement would just be, what is that, 10, back 5, then I'm going to go 15 more. So where does that end up? It ends up at 10. Is that right? It would end up at 10. So, well, 5. So I'm at 5. I'm going to go 15. No, it would end up at 20. So this would end up at 20. But that's the displacement. Displacement would be 20. But what is the total distance traveled? Well, it's 10 plus 5 plus 15. So that would be 30. That would be the total distance traveled. So this would be positive, this would be negative, this would be positive. So if you wanted to use an integral, you just take the absolute value of the velocity. That gives you total distance traveled. Okay, now let's do a problem that we can look at and try to figure it out together. So let's say I gave you this problem. I said the velocity of a function is equal to, and I'm just going to give you a function, y is equal to, so the velocity, let's get rid of that. We're going to need a lot of room to work on this problem. So I'm going to say that the velocity is equal to x minus 4. And I want to know what the displacement is from, let's go from 0 to 10. And I also want to know what the total distance traveled is between 0 and 10. Now, this one we could do algebraically. Should be no problem because I can graph this out. X minus 4, that function isn't bad. So I go 1, 2, 3, 4. So it starts here, and the function looks like this. Okay, this is 0. Let's say that this is 10. It's going to cross at 4 here, isn't it? So between 0 and 4, it's below the x-axis. That means this particle is moving to the left. Between 4 and 10, this particle is above the x-axis. It's moving to the right. Okay, so anything below, moving to the left. Anything above, moving to the right. So how far, what is the displacement of this function? Well, guess what? I'm going to find the area underneath this curve. So this is a 4 by 4, so this is 16 by, so this is 8 right here. So it's going to go to the left 8 units. And then, what is this distance here? This is 6. If I put 10 in here, 10 minus 4, that's 6. So this point is 6 here also, so this is 6. So this is 36 divided by 2 because it's a triangle. It's 18. So if I wanted to find the displacement on a number line, here's 0. This particle is going to go 8 units this direction. So it stops at -8, and it turns around, and it goes 18 units this way. Where did it end up? Okay, where did it stop? Because that's the displacement. The displacement's where it stops. So what is my displacement for this problem? 10. Correct. The displacement is 10. What is the total distance traveled? So now I take both of these pieces and I add them together because total distance is, you know, how far did the thing go totally? So what is my total distance traveled? 26. Agreed. All right. Now, if I was going to do this using calculus, integral from 0 to 10 of x minus 4. Okay. Well, I know how to take an integral. Okay. So this is going to be x squared over 2 minus 4x on the, and remember when we take the integral, it's from 0 to 10. So now I'm going to plug 10 in here. 10 squared is 100. 100 divided by 2 is 50. So this is going to be 50 minus 40. So that's going to be 10 minus, and then I'm going to put 0 in there. Well, that's going to be 0, and that's going to be 0. Boom. My answer is 10. That is the displacement. I just came up, I used calculus, came up with the exact same answer that we came up with if we did it just using our thought geometry. So do you guys understand how I came up with that 10 there? Now, I cannot find the total distance traveled without using a calculator because I can't just take an absolute value here. Now I can, you know, obviously I can look at this and say, oh, that's an absolute value of x minus 4. I know what that graph looks like. It looks like a graph that's over here. So I could actually do it if I wanted to, but that's not the point here. I'm going to show you how to use a calculator. So I want you to get your calculators out, okay? Now I'm going to ask you a question, and I want to see if you can see this. I'm going to try to share something with you. Okay, so I'm going to try to share something, and I don't know if it works or not. So let me try this and try to share a screen with you. So I'm going to share my entire screen with you. Let's try a window. All right. Can you see my graphics calculator? Okay, can you guys see that or not? All right, I didn't think so. Darn it. I don't know how to do that then. Okay, because I have a TI-84, but I thought I could share it with you guys. Okay, let me try one other. Let me try one other thing. See if I can try it a different way. Share application screens. Let's go window. Yeah, this is really. That's not a Chrome tab, so I can't share that. Okay, I'm not sure I can share it. Let me go with tires. Yeah, because it's not going to share that either. Can you see it now, by any chance? I don't think you can. All right, can't see it. Okay, so I'm going to do it a different way. I'm going to use Desmos to show you, and you're going to have to try to figure it out on your calculator. It does work, trust me. I have a graphics calculator sitting here, so I do know that it does work. So let me try doing it this way. I'm going to share Desmos here with you guys. It's not working. All right, Chrome tab, Desmos. Okay. All right, so you should be able to see my Desmos screen right now, right? Okay. Now I've already plugged in this problem. I plugged in the integral from 0 to 10 of x minus 4 dx, and I came up with 10. Then I did the absolute value. I did the integral of, now your calculator has the exact same thing on it, okay? So what you need to do is you need to go to, okay, I'm getting my calculator out. Now, what type of calculators do you guys have? TI, hope? All calculators are basically the same. So do you guys have TIs? Okay. Oh, the TI-84 plus CE, that's the one I have on my screen, but I can't share it with you guys. Okay. So I have a TI-83 sitting in my hand right now. So I'm going to, oh, you have a Casio. That's a whole different ballgame. But I will tell you, it will do the exact same thing. I don't know Casio like I know the TI-83, but it will have an integral symbol in it. I know it does because I've taught many years in school, and kids had the Casios. So now you're going to, for the Isabel, you're going to go to the math button, and you're going to scroll down to, I believe it's number 9. It should say fint. Do you see that? Okay, hit enter. Now, the 84 could be a little bit more advanced than mine, okay? Mine is a TI-83, so I'm a little bit behind. I don't have the 84. Some calculators have exactly like the Desmos presentation where you can just plug in the values. I think the Casio does have that. I think the Casio has where you can just plug in the 0 and 10. But I think does yours have the fint, Isabel? Okay, so what you're going to do is you're going to plug in the function. So you're going to plug in x minus 4. You know how to plug in the x minus 4? Nope, nope. Right where it should say fint, and then it'll have a parenthesis, and then you're going to plug in x minus 4. Okay. Oh boy, I think I put a negative in there instead of a positive. Okay, so what you're going to do is you're going to put the function in. So put in x minus 4. Okay, and then you're going to put comma. And then it's going to ask you for, so once you put the comma in, you're going to put comma x. So let me go back to the screen here, our class here. Let me get back here. I'll go back down to, okay. Oops. Okay. So what you're going to do is you're going to put in, so what is it? F int, which is the integral. Then you're going to put in the function, comma, the variable you're using, comma, where do you start, comma, where do you stop? Okay. So yours would look like this: F int x minus 4, comma x, comma 0, comma 10, and then hit enter. What do you get? Oh, all right. So if you just have the fill in the blank spots, this is an older calculator. Yeah, your calculator is much nicer. You can just put in the function. Awesome. So your calculator is very much like Desmos. Okay. Esther, how about yourself? Have you found the F int or the integral symbol on your Casio? All right. Which type of Casio do you have? You're probably going to have to get your manual out, or who cares about manuals these days? Just type in, go into Google search, and then just type in the type of calculator you have and what you want to do. You want to take an integral, and it will give you the thing, because you really want to be able to do this on your calculator, because part of the exam is calculator based. Okay, now Isabel, I want you to do the same thing. You got 10 for an answer, right? The exact same answer that we got 3 ways now. We did it by graphing. We did it, let me see if I have that page still. Yeah, we got 10 by graphing it. We got 10 by using the number line. We got 10 by using calculus by hand. Now we have 10 using the calculator. Now I want you to find the distance traveled. Well, how do you find that? Well, you're going to do exactly the same thing, except you're going to put it in absolute value. You're going to put the x minus 4 inside an absolute value symbol. Okay? Do you know where the absolute 25.99? That's exactly what I came up with. Is 25.99999 the same thing as 26? And the answer is yes. It's just the way the calculator works, but that's basically 26. So now you know how to use your calculator to find integrals. Your calculator also finds derivatives, but we'll talk about that some other day, because we got some stuff to get through still today. Okay? So your calculator will find an integral for you. And when we start doing areas and volumes, all the problems deal with calculators. All right? So this is a big part of today. It's finding displacement and total distance using your calculator. All right, so here's the problem. It says the velocity of a particle moving along a line is t to the third minus 10t squared plus 29t minus 20, where t is time in seconds. What is the displacement of the particle on the time interval between 0 and 5? What is the total distance traveled of the particle between 1 and 5? So these are the types of problems that I would expect students to start using their calculators on. I would not, now could you solve this problem using calculus? Sure, I could. I don't want to, but I could. What I want you guys to do is I want you to use your calculator to find this. So what are you doing? Well, remember, displacement, okay, is just the integral of velocity. So my displacement is going to be in this problem 1 to 5 of, and then t to the third minus 10t squared plus 29t minus 20. And that is on from 1 to 5. Boom, put in your calculator. What did you get, Isabel? Now, Esther, I mean, you can obviously follow along here. You could also go to Desmos and do it. Do you want me to show you how to do it on Desmos? How to find all the function pieces? Okay, so on Desmos, let me go back to Desmos and let me write this problem down so I don't forget it, because I'm old and I will forget. All right, so this is the integral from 1 to 5, t to the third minus 10t squared plus 29t minus 20. Okay, let's see here. So Isabel, you got 10.67. Find the total distance traveled then, okay? And then I'm going to show Esther how to do it on Desmos. Okay, so if I have to use Desmos, I'm going to get back to Desmos. Oh, I did this wrong again. Okay, so I want to share application screen, Chrome tab, Desmos. Okay, so I'm going to get rid of these two. Okay, on Desmos, if I'm going to use Desmos, I just go to functions. Let's see here. Can you see that? You should be able to see it. Okay, so in Desmos, I go to functions. I just scroll down until I find the integral symbol. They have all the calculus stuff right next to each other. So I've got integral. Where do I start? Where do I stop? So that's 1 in this problem and 5. And then my equation. I usually put in parentheses. So it was, oops, I want to make sure if somebody has a question here, I want to make sure I get it. Okay, so Isabel, you got the answers? Okay, all right. So now I'm going to put my function in there. So x to the third minus 10x squared minus 10x squared plus 29x plus 29x minus 20. And then I'm going to put dx behind it. Its derivative. And I get 10.6667. All right, is that what, Isabel? Yep, you got the same thing. Okay. Esther, does that make sense? All right. Now, if I wanted to do the absolute value, okay, I just have to use the absolute value symbol. So I'm going to do it again. I'm just going to go to functions. I'm going to find my integral symbol. And here, okay, I'll go back 1 second. So I've got 1 to 5. And this time I'm going to use absolute value symbol. Okay. And then I'm going to, I don't know if I can copy and paste this. It'd be awesome if I can. Not sure if I can. Let's see if I can copy that. Nope, doesn't let me. Okay, so I'm just going to put that in. So x third. Oops. I messed something up there. Let's get rid of that. So this is going to be x to the third minus 10x squared plus 29x. Symbol. Oops, I needed to delete that because it already was there. Put that there, and then dx. I came up with 11.83. And that's exactly the same thing that Isabel came up with. So you should be able to, play around with your Casio, but also check your answers on Desmos because it does work. Now, let's say I gave you this problem. All right. We get to get back to our screen here. All right, I'm going to give you this problem, and I want to see if you can. Okay, if I gave you f of x, sorry, I'll do this pen and paper. If I gave you f of x equals x squared, and I asked you what f prime of 3 was equal to, what would you say? You should be able to do that in your head, right? I mean, that's a pretty easy derivative, plugging 3 back into it. Pretty easy answer, right? So what would my answer be there? What would f prime of 3 be? 6, exactly. Okay, so now how would we do that using a calculator? Now, Isabel, on your calculator, you should have, if you go back to math again, oops, if you go back to math, go down to, I think it's number 8. Nope, yep, number 8. It's n-deriv, or something that looks like that, n-deriv. Same concept, okay? Now, if I was going to use the, if I wanted to use Desmos, so let me go to Desmos again. Sorry, I'm going back and forth on tabs. Okay, so let's say I wanted to do Desmos using the derivative function. So I just go down to the derivative, and that's f prime. Oops, I haven't played around a lot with this. I think, I should have played with this more. Okay, so let's go d dx and let's go. Nope. I think I did one. Let's go f of x equals x squared, and then let's go down to the next one, and then do f prime. So now f and if I don't, I'm not going to waste a lot of time with this today. I know it works. I haven't played around with this. So f prime of, let's say, 3. Yeah, it does work. So it gives me 6. So, and we did know that. So you have to put your function in and then just go f prime of whatever number you want, and it will give you the derivative of that. Okay. Now, Isabel, were you able to get that on your calculator? Were you able to get 6 for an answer when you did x squared? Okay. So Isabel, you know how to find a derivative and integral using your calculator. Good, because you're going to need that a lot in the next couple weeks, especially when we start doing area between curves and volume of rotation. Okay, so here's the answers. 32 over 3, which was the exact same answer that we had. Okay, now, an initial value problem, when you start dealing with calculus, a lot of calculus deals with position, velocity, and acceleration. Position, the derivative of position is velocity. The derivative of velocity is acceleration. So now that we know what integrals are, we should be able to go back and forth. So if they gave me an acceleration function, I should be able to take an integral of that and go back to the velocity function. If I take the integral of velocity, I get position function. So the derivative of position is velocity. The derivative of velocity is acceleration. But then we can go backwards and we can say, well, the integral of acceleration is velocity. The integral of velocity is position. Very, very important concept in calculus. So what is a type of problem that they give you? Here it says a particle moves along the x-axis so that its velocity at time t is greater than 0 is given by, and they give us a velocity function. Then it says the position is 5 when t equals 2. Write a polynomial expression for the position of the particle. Oh, how cool is that? That means that what I'm looking for, so I have velocity, I have a velocity function, 3t squared minus 2t minus 1, but I want to get the position function. Now I could get the acceleration function really easy. I just take the derivative. But to go backwards, I have to take the integral. So I would do the integral of 3t squared minus 2t minus 1. So what is that going to be? That's going to be 3t to the third over 3 minus 2t squared over 2 minus 1t plus c. So if I reduce this down, t to the third minus t squared minus 1t plus c. And they gave me a value. They told me when t is equal to 2, the position is 5. So 5 is equal to, and I'm going to plug 2 in here, 2 to the third is 8, minus 2 squared, which is 4, minus 1 times 2, which is 2, plus c. I'm trying to solve for c, so I know what the exact position function is. So 8 minus 4 is 4, minus, that's 2. So if I subtract off 2 from here, that gives me c is equal to 3. So my position function is t to the third minus t squared minus 1t plus 3. How cool is that? We can go back, given a velocity function, we can go back and get the position function as long as they give me an original point on there. That is some cool stuff. I mean, seriously cool stuff. All right, any questions on that? All right, here's a problem for you guys to try. Okay, it says a particle moves along a straight line with velocity t squared. How far does a particle move between times t1 and t2? Okay, now this would be a calculus problem for non-calculator, I would think, but you can use your calculators to just try this, or use Desmos just to try it. I will do it by hand. I want you guys to use technology. So Isabel, you use your graphics calculator. Esther, you use Desmos. See if we get the same answer. So particle, how far does a particle travel? So 1 to 2 of t squared. So what is that going to be? That's going to be t to the third over 3 from 1 to 2. If I put 2 in here, that's 8 over 3 minus 1 over 3. So 7/3. And I got it faster than you guys, and I was using a calculator. I was using just regular math. Did you guys get the same thing? What is that, 3.33? No, 2.33. Is that right? 2.33. Okay, awesome. So these types of problems, they come up all the time. All right, now we have one more thing to go over today. Average mean value theorem, the average mean value theorem. It is just the average of the area underneath the curve. Okay, so when it says the average mean value, what you do is you just find the area underneath the curve, you divide by the interval. So an example of that would be something like this. And I had a problem written down so I didn't have to make this up all over again. So what I want you to do is I want you to find the average value. My function is y is equal to x on the interval from 0 to 10. Okay? So I can just put 1x here if I wanted to. Now, visually, it's going to look something like this. 1x just looks like this, doesn't it? Just this graph. So if I go from 0 to 10, that's going to be 10 here. That's going to be 10 here. So this is going to be 50, isn't it? So the area underneath this thing, total area is 50, but it's on an interval. So I want the average value. So I'm just going to take 50, divide by 10, and I get 5. That is the average value. So if you drew a line at 5 here, you drew a line like this, the area underneath this line should be exactly the same as the whole thing. It is the average value of the function. So it's super easy to find. You shouldn't have any troubles. Let's try an example. So here it says, find the average value of y is equal to the square root of 64 minus x squared on its domain. Okay. Now, you guys can use your calculators if you wanted to. I'm going to use just regular old math. What does the graph of this look like? What is that graph? What is the graph of 64 minus x squared? What is that graph? Does anybody know? These should be really easy for you. Okay. It is a semicircle. Because remember, a circle, x squared plus y squared is equal to r squared. That's a normal circle. So if I had x squared plus y squared equals 64, and I rewrote this thing as y is equal to, I'd subtract x squared off, so I'd end up with y squared is equal to 64 minus x squared, and then I take the square root, plus or minus. It's only positive, so that means it is the top half of the circle. And what is the radius? It's 8. So if I was going to do this by hand, I know it's a half of a circle. A circle is pi r squared. It's a semicircle, so I'm just going to divide through by 2. So what is that going to be? 32 pi? 32 pi is the area, but they wanted the average value. So I take the interval, 8, negative 8 to positive 8. That is an interval of 16. So if I divide through, that gives me 2 pi. So my answer should be 2 pi. Now, if you used your calculator, remember at the very end, you're going to have to divide. You still have to divide by the interval, because if you don't, you're not going to get the correct answer. Okay? Any questions on that? So the average value, you just find the area underneath the curve, then divide by the total distance. That's it. Now, the last thing, because we're going to review f prime graphs. We did a lot of this first semester. All right. I remember, Isabel, you struggled on some of these. This problem is on your assessment this week, okay, on the f prime one. This is a great problem. This was a AP question in the past. I'm going to skip part A right now. Okay, you're getting flashbacks. I'm going to skip part A right now, and I'm going to go to ones that I think you should know right off the top of your head. Okay, now this is, and I tell this to students every year, this is an AP question. All AP questions, there's 6 of them, they're worth 9 points. If you can get 5 out of the 9 points on each one, you will get a 5 on the AP test. So how it works. Okay, so this one, okay, let's get 5 points. Part B, on what intervals is f increasing? Justify your answer. How do we know this is a derivative graph? Where is the original graph increasing? Where is the original graph increasing? Oh, come on. I know you guys can do it. Where is it increasing? When f prime is positive. So when it's above the x-axis. Anytime the graph is above the x-axis, it's the original function is increasing. So for part B, I would say between -6 and -2, it's increasing. And between 2 and 3, 4, 5. Between 2 and 5, it's increasing. And justify your answer, it's above the x-axis. The derivative graph above the x-axis. That's all you have to say. Where is it decreasing? Well, it's decreasing from -2 to +2. Now we have to do part A, because part A is going to help us with part C. Okay? Well, no, let's do... No, let's not. Okay, so part A, it wants us to find f of -6 and f of 5. They gave us a function. It says the function is differentiable between -6 and 5, and it satisfies this piece of information right here. This is really important, because this is how we're going to write our integral out, because the integral is the area underneath the curve. Well, at -2, it equals 7. So what we're going to do is we're going to go 7 plus the integral from -2 to x. That's going to be what we're going to use to solve these problems, because we know, because if this was -2 right here, right, from -2 to -2, what would my answer be? Well, remember, if you go from -2 to -2, that's 0. 7 plus 0 is 7. So at -2, my integral does equal 7. But that's not the question. The question was, what is negative 6? So I'm going to use my formula. I'm going to go 7 plus the integral from negative 2 to negative 6. Okay, there's a problem here. Can you see my problem when I set up my integral? And I try to hammer this in. You can't have a smaller number on top. So how can I rewrite this integral? How can I rewrite this so the smaller number's on the bottom? How can I rewrite that? Inverse it. Yes, but what do you have to do if you do that? You have to make this a minus. So 7 minus the integral from negative 6 to negative 2. So what does this tell me? It tells me to find the area underneath the curve from negative 6 to negative 2. That's what this means. So from negative 6 to negative 2, what's the area? 1, 2, 3, 4. So that's a triangle. So that's 4 times 2, which is 8. So this is 4. So my whole problem to find f of negative 6 just turns out to be 7 minus 4, which is 3. F of negative 6 is equal to 3. Now, if I want to find 5, I'm going to put 5 in here. Do I have to flip this around? So now I have 7 plus the integral, that's a 7, negative 2 to 5. I don't have to flip this around anymore because the smaller number's on the bottom. But I do have to find the area, because this really means what is the area between negative 2 and 5. So from here, from negative 2, 1, 2, 3, 4, 5, to here, that's the number that I have to put in here. So this, oh boy, what is this? 1, 2, 3, 4. Sorry about that. So this is a semicircle. And that semicircle, what's the area of that semicircle? Well, semicircle is pi r squared divided by 2. The radius is 2, so that gives me 4. So if I divide that, that's 2 pi, isn't it? But guess what? It's under the x-axis. This is negative 2 pi plus the area of this triangle. 1, 2, 3. So the base is 3. The height is 2. So that's 3 times 2, which is 6. So that's 3. And there, this, so f of 5 is equal to negative 2 pi plus 3. Okay. Every AP exam has a problem like this. Everyone. Okay. And then it says, find the absolute minimum value of f on the closed interval. All right. Well, whenever you have to find an absolute minimum, you have to try out the endpoints. So I have to try out f of negative 6. I have to try out f of 5. I have to try out, well, guess what? Wherever it crosses the x-axis. So this is increasing, then decreasing, increase, decrease. This is a maximum value. So I don't even have to check that out. It's maximum. This point crosses again. So at 2, I have to check this out because it's decreasing, then increasing. That's a minimum value. So I have to check out f of 2. Well, guess what? I know what f of negative 6 is. It's equal to 3. I know what f of 5 is. It equals negative 2 pi plus 3. We already figured that out up here. The only thing I really have to figure out is what is f of 2? Well, guess what? F of 2 is 7 plus the integral from negative 2 to 2. Well, isn't that going to be 7 plus, what is the area underneath this curve? We said it was negative 2 pi. So this is 7 plus negative 2 pi. Negative 2 pi is like 6 point something, right? So 7 plus negative 6, this is a pretty small number. This is the smallest value. So I would say that this is the absolute minimum on this interval. Now, let's take a look at the answer key to this thing. Part A. We have 7, so this is their answer. They came up with 3, and then 10 minus 2 pi. I'm sorry, I missed something. on part. I forgot the 7. I figured f of 5. This is not f of 5. That is the area from here to here. I forgot to add the 7 back into it. Remember, you have to have that 7 added onto it. So this really should have been negative 2 pi plus 10. Sorry about that. I missed adding on the 7. Okay. So here's the answers. So f of negative 6 is 3. We came up with that. F of 5 should be 10 minus 2 pi because I forgot to add the 7 on. Part B, where is it increasing? Negative 6 to negative 2 and 2 to 5. Okay, and it's because the derivative is greater. Then, so if you take a look here, part A, that was worth, the year that this AP exam was given, part A was 3 points. Part B was 2 points. You already have 5 points now. You don't need any more points. However, trying to get as many as you can, because some of them you're going to look at, and you're going to look at the problem and like, I don't know how to do that problem. And then part C, we considered x equals 2. That was 1 point. Answers with justification. So our answer was 7 minus 2 pi, 2 points. So now I'm up to 7 points. I didn't even do part D in this problem, and I already have 7 points. Now part D, it asks us, it says for each of f double prime of negative 5 and f double prime of 3, find the value and explain why it does or does not exist. So I'm gonna erase all this. So f double prime, so this is the first derivative. So the second derivative would be the slope of the first derivative, wouldn't it? So if you have the first derivative, the second derivative would just be the slope. So what is the slope at negative 5? Well, negative 5 is right here. What is the slope of that value? Well, I'm just going to take negative 6, 2, because it's on this line, right? So the slope would be the same as this line. And what is that? Negative 2, 0. So 0 minus 2 over negative 2 minus negative 6. So that's negative 2 over 4. So negative 1/2. So f double prime of negative 5 is negative 1/2. It's just a slope. Same thing with f double prime of 3. It's a slope right here. Well, guess what? We learned that there is no slope when there's a corner, a cusp, or if it splits. So this one does not exist. And if I look at the answer key, that was 2 points to tell, did I find the slope wrong? Oh no, right up here, negative 1/2. Okay, phew. And f of 3 does not exist because it's a corner or a cusp. Whew. All right. So we did a lot today. We talked about derivative graphs. We talked about position, velocity, and acceleration, how to find the displacement and the distance. And we also talked about the average value. Whew. And it is 3 o'clock almost. Any questions before I have to run to my BC class? I would suggest that you guys use your calculator this week. Try to use that technology, because on the AP test, now you'll notice, like this problem, there was no way to use a graphics calculator on this, right? But on the position, velocity, and acceleration problems, absolutely use your calculators, and hopefully you should be, get comfortable using that. All right, you guys have a great week. I will talk to you hopefully next week. Bye.